Hey guys, welcome back to my channel, and today we will be discussing about bipartite graphs. Okay, bipartite graphs. Okay, let us first delve into the basics. What is a bipartite graph? Okay, suppose you have two sets. Okay, one represents. Okay, so one represents girls. Okay, one, two, three, a set of girls. These are girls. Another represent the set of boys. Okay, so let us write it as G1, G2, G3, G4. Let us see the example of a dating app. Okay, B1, B2, B3, B4. Okay. Now, we will draw an edge if G1 uh, likes the boy P1, or G1, whoever she likes, we will make an edge. Okay. We know that in a dating app, edges cannot be within the same set. So in a bipartite graph, we can partition the graph into two sets such that edges are only across the sets and not within the set. That means we can have edges like this. So G1 likes B1 and B3, G2 likes B2 and B4, G3 likes suppose B2 and G4 likes B3. Okay, so this is a bipartite graphs. No edges should be within the same set, because in a dating app we know that uh, within the set girls there cannot be an edge, and within the boys there cannot be an edge. All the edges are across the sets. Okay, this is the example of a bipartite graph. Okay, so let us move on to some results about the bipartite graph. So, a bipartite graph, number one, bipartite graph. If your graph is a bipartite, you know this is true. This implies that there are no odd cycles present in your graph, no odd cycles. And its proof is also very easy to look at. Okay, I will tell you the intuition. If it is true, if you know your graph is bipartite, then you can conclude that there are no odd cycles present in your graph. Let us see the example of a bipartite graph. Okay, three nodes over here, we will take an example, and four nodes over here. Okay, set A, set B, this is A1, A2, A3, B1, B2, B3, B4. Okay, now suppose, let us see if there are odd cycles present, then can that graph be a valid bipartite graph? And we know that a bipartite graph, within the same set you cannot have edges. Okay, so we start from A1 to B1. This is a path of length 1, then again path of length 2, right? And then path of length 3, right? Now, 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 and again I will draw an edge, path of length 4. Now this is a path of length 4. Now to make it an odd cycle, I have to go back to A1, right? But from A3 I cannot make, I will have to make from A3 to A1 like this. But that violates, because A1 and A3 are in the same set. So that means that violates the condition of a graph being bipartite. Okay, so that means you cannot have an odd. If you know the graph is bipartite, then you are definitely for sure you cannot make an odd cycle, right? So from A3, this was 1, 2, 3, 4 length has been done. Fifth length, now you can come back to make a 6 length cycle. So all even cycles are present, or no cycle can be present, but odd cycles cannot be present. So let us see the reverse of this theorem as well. If there are no odd cycles present, can you say your graph is bipartite? So the second property is, if there are no odd cycles in your graph, you know this, there are no odd cycles, will your graph be a bipartite graph? This is the question. Can you conclude if no odd cycles are present, that means uh, your graph is bipartite? Let's see. Okay, we'll make a sample graph. Okay. See, in this graph, I will label the edges A, B, C, D, E, F, G, H. In this graph, all cycles are of length 4. None are odd length cycles. Okay, so this is true. No odd cycles are present over here. Now let us do what? We will color. Okay, we will suppose we start from vertex A. Okay, we kept vertex A over here, and whatever vertices are adjacent to this vertex A, I will draw it in a separate set like this. Okay, one distance. Now B, ruko. So A is in one set, and whatever vertices are adjacent to it directly, they have edges with A. I am putting it in another set B. Okay, with a different colors. So B, E, and D. Right? We will keep it over here. B, E, and D. Now this is level 0. This is from A. This is at distance 1. Now we will draw the neighbors of B, E, D. Whatever edges are adjacent to B, E, and D, we will make another set of those. So what edges are adjacent to B? A we have drawn, F and C. F, C adjacent to B. Then from E, what are adjacent? F and H. Okay, F and H. And from D, what are adjacent? H and C. H and C. Okay, this is level 2, 2 distance from vertex A. Okay, now yes, so notice over here, whatever vertices are at level 2, we will highlight those vertices. Right, the vertices B, C, B, sorry, F, C, F, C, H, right? F, C, H, yes, these are the vertices. They are not adjacent to vertex A. None of them are adjacent to vertex A. So what we can do, we can put A, F, H, C in the same set. Okay, one vertex G is left out. So G is adjacent to F and H, right? So that would be at level 3, right? F, C and H all are adjacent to G. This is level 3. Okay. We use another color. Okay. This is at level 3. So all the yellow is at level 0, the blues are at level 1, the greens are at level 2 from A0, and the white is at level 3 from A0. Okay. So what we can do over here, we know that our adjacent vertices should be in 2. To be, for this graph to be bipartite, our edges should be across the set. So what we will do is, we will put level 0 in set 1, level 1 as it is adjacent to A, so it has to be put in set 2, Now I know that level 1 and level 2 are adjacent. Again, I have to put it in the first set A. And I know that level 2 and level 0, we can see from the diagram, the green and the yellow, does not have any edge. So I can aram se put level 2 into set 1. So I will put it into set 1. Now level 2 and level 3, they have direct edges. So we cannot put them in set 1. So we can put it in set 2. I know that the white and uh, the white one and the level 1, the blue ones, they don't have any adjacent vertices, right? So what we are doing is we will move on to the next page. Okay, what I'm saying in, we will have two sets, set 1 and set 2. We will put the level 0 in set 1. Level 0 has direct edges with level 1. Then level 1 has direct edges with level 2, right? And level 2 and level 0, we can see they don't have the yellow and the blue, they don't have a level 2, right? The green and the yellow does not have any edge. And level 2 has direct edge with level 3. And level 3 was our white one. White does not have a direct edge with the blue ones. So we can put it over here like this. So yes, our graph, if it doesn't have any odd cycle, so it is bipartite. It can be bipartite. So there is another graph coloring property, that a bipartite graph is two colorable. Minimum colors required so that adjacent vertices, they don't have the same color. This is what we are doing now. Adjacent vertices, they are in separate sets. That means minimum, if I color all the nodes in the set 1 as with one color, say yellow, all the vertices that are in set 1, they don't have an edge, so they can be colored with the same color. And if I color the all the nodes in the set 2 with another color green, so yes, it is two colorable. That is also valid, that bipartite graphs are two colorable. Partite graphs, they are two colorable. Okay, and how is this thing useful? If you see any graph that is two colorable, you can conclude that it is bipartite. It does not have any odd cycles present in it. So it is useful for examples of allocating resources to two groups of people, or dating app, it can be a use case, or job assignment can be a use case of bipartite graphs. So that's it for today. Hope you enjoyed this session, and I want you guys to be better than you were yesterday, and have fun with the graph theory. And please look out for more examples where bipartite graphs can be seen in the real world, where you have seen it around you. And bye bye and take care. Happy learning. Please like, share and subscribe to my channel, share it with your friends, and enjoy the learning of discrete mathematics.